Have you ever asked for a photometric report and been given a sheet of paper or PDF instead of electronic data file with IES as the extension? Since lighting software cannot read a PDF file, much less a piece of paper, you or someone will need to create a proper photometric data file or IES file from scratch. This could be done in Notepad if you are feeling ambitious, but I can tell you that it's much easier to do in Toolbox. Before you begin, you'll need to make sure that you have all the information that Photometric Toolbox will need, some of which is shown here. And here's some more of the information that's going to be needed. As we go through the process of creating a file, you'll see how this works. Here's an example which I made up for this presentation of what a very basic paper report might look like. Based on this, we have a 6-inch diameter recessed downlight. There's one lamp, 70-watt T6 metal halide, which has 6,600 lamp lumens. The luminaire has 79 watts. And most important, we have a candela table showing the candela values or intensity values at the various horizontal and vertical angles from the test report. So let's go to Photometric Toolbox and create a new file for this pretend luminaire. We'll begin by selecting the button to create new report, new photometric file. We'll enter the value here, one lamp, 6,600 lumens, candela multiplier. Assume this is 1 unless the data that you have indicate otherwise. Ballast factor, again, assume 1 unless the data indicate otherwise. And then input watts, 79. Now for the luminous dimensions, we're going to select circle over here, circle. Note that we're entering luminous dimensions here, not our luminaire's overall physical size. This information should be found in the data that you were given. Our recessed can has a luminous opening of 6 inches. I'm working in feet, so that means I'm going to enter 0.5. If you have a metal halide lamp or another kind whose light output is affected by its position, you may want to include the appropriate lamp tilt data here. There's a box to check if you have that information, lamp tilt data, but we don't, so I click the next button. And this is now step 3. We skipped step 2 because we have no tilt data to enter. The keyword test up here refers to the test number. I'm going to make one up, right, because this is for pretend. Test lab, I'm going to enter a bogus test lab name. Issue date is the date of the test. Don't just make it up, put in something correct. Manufac is the manufacturer's name. LumCat is the luminaire catalog number. Again, you wouldn't be making this up like I am. You would be putting in the real information. Luminaire. This is where you can enter a description for the luminaire. So I'm going to put in 6-inch recessed, 6-inch, I can spell, diameter recessed downlight. LampCat is for the lamp catalog number. It's optional. If you want to skip over it, you can. Lamp, you should put in a description of the lamp. 70-watt, T6, metal halide. Note that you can add more lines here, right? Click in this little last blank field to get a little down arrow here, and you can pick from a whole bunch of stuff. Some of this stuff is not IES. They're not IES keywords. They belong to CIBSE or EU LUMDAT. And then down at the bottom we have more, which you could select if you needed more room for a lengthy luminaire description perhaps. Continuing on to step 4, this is where we tell Toolbox whether this is type B or C photometry. Since it's not a floodlight, then we pick type C. And now this is where you need to know how many vertical and horizontal angles the luminaire was tested at. Depending on the format of the data that you have, you might have to go to the table of candela values and count the angles along the left side and across the top. Most of the time, you'll be able to pick from one of the standard sets of angles that are given here. And so I'm going to select 10 angles for the vertical number of angles and 10 degree increments. And for horizontal, I'm going to select 1 horizontal angle. This luminaire is symmetric all the way around, and so only one horizontal angle's measurements are reported. Typically, the luminaire's light output is measured all the way around, and then the values are averaged, and only one horizontal angle is actually reported. Continuing on to step 5, now I'm going to fill in the candela values. And hitting the Tab key takes me to the next level down. It's like watching grass grow, isn't it? Notice that you can see the vertical slice over here developing as I go. If I make a big boo-boo, it would look wrong, right? And so I have a little visual confirmation that I'm doing this correctly. Here I'm going to type in, I'm going to make a typo, type a little mistake, and then I'm going to fix it later with the edit command. And then I can see the whole thing developed over here. Aren't you glad that I didn't choose a luminaire with 5 horizontal angles and 37 verticals? Wouldn't have that been fun to watch? Okay, so notice that the polar curves have been drawn, as I mentioned. And so we'll go on to the last step, step 6. And this is the point where you can choose to finish without saving the file if you like, or you can save it. It's more likely you're going to want to save it. So you click on Finish and Save As. Type in a name, pretend MH fixture. Save. And notice that that newly created file is now over here.